And hello all, Mr. Callen here to help you with the next lesson, starting up a new unit. So without further ado, let's get into it. All right, I'm going to invite you to open up to page 759. Press pause, see what you can come up with, and come on back when you're ready. Go ahead and press pause right now and come back when you're good. So interestingly enough, you might have taken this a number of different ways. I immediately latched onto, well, we have two sets of 5, and then we have 1, 2, 3, and 4 sets of 8. On the flip side, perhaps you noticed that we have two 4x4 squares and an additional 10. Okay, you might see where we're heading now. Because somebody might say, hey, I see 6x8, and then what they did was they canceled out or subtracted two groups of 3, a 2x3 rectangle. And of course, perhaps you'll also notice a 5x6, which at first I did not notice. The point here is, as long as you can explain it, there are different ways to see visual patterns. And that is our goal for the day. Goal for today's objective, we want to just explore. We're not looking for mastery today, but explore a new type of visual pattern. So you can see an example there. Now, just a reminder of where we've been with visual patterns. When it comes to something that is linear, a linear relationship will have what's called a common difference. So 7 take away 3 is 4, and 11 take away 7 is 4, and 15 take away 4, and so on and so on. In fact, every time the step increases by 1, the number of the pattern increases by 4. Excuse me. On the flip side, there are such a thing as nonlinear relationships. So for instance, if we took a look here, it seems to increase by 12, but it does not increase by another 12. This goes up, what, 50, 48? And so that is not a linear relationship. There is no constant rate of change. There is no slope. On the other hand, there is still a pattern, ladies and gents, but it's not a linear pattern. In this particular case, there is not a constant difference, but there is a constant ratio. So if you did 16 to 4, or 64 to 16, or 256 to 64, the ratio is 4. In fact, every time, if you want to find the next number in the pattern, you would simply multiply this by 4. Remember, please, linear is not multiplying. It will be an add or subtract. And I have no idea what 65,536 times 4 is, but I bet you could figure it out. So that was what we called an exponential relationship, when there's a constant ratio. And you would do that by saying, what are we multiplying by? As opposed to a constant difference where you would say, what do we add or subtract by? That's linear. All right, page 760. I want you to take a look at these. See what you can do with 2 and 3. Pause the video, come back when you're ready. Go ahead and pause now, please. All right, first 3 steps in a pattern. Taking a look at what we see here. What about it is changing and what is staying the same? Well, I see something that is increasing. The S, I know that seems obvious, but every time the S goes up by 1. Meanwhile, the purple set of blocks increases. It gets wider, it gets taller. Maybe you said that there is a square in the middle. Perhaps you notice that. Things staying the same. Well, no matter what, every time we seem to have the same 1, 2, 1, 2, 1, 2 blocks on either side. Perhaps you can find something else that is staying the same. As for the pattern, again, if you haven't done this, pause the video, come back when you're ready. But if you notice, if there is that one constant block, and before we had a square that's 1 by 1, and then we had a 2 by 2, and then we had a 3 by 3, which I suppose means the next one is going to be a 4 by 4. With those at the end, and I'm just going to have some fun and color it in. But perhaps you will see the same pattern that I have seen, which means this fourth one would have a total number of how many? 1, 2, 3, 4, 16, 17, and 18 blocks. So how many tiles were there to be for the 10th step? Now again, perhaps you saw the square changes. So we have a 1 by 1, and then we add 2. Here we have, so that would be obviously 1 times 1 plus 2 is going to give us 3 blocks. Next up, instead of 1 by 1, we have a 2 by 2, but we still add the same 2. So we have 4 blocks in the middle, 5, 6. Next one, 3 by 3, with the 2 blocks on either end. 3 by 3 is 9, plus those 2 is going to be 11. So a 10 by 10, imagine the 10 by 10. I'm going to draw this without doing it to scale. There's still going to be a 10 by 10, so that's 100 blocks, plus 1 plus 2, for a total of 102 blocks. I hope you got the same thing that I did. Now, let's go ahead and keep exploring, shall we? Again, if you haven't taken a look at this, go ahead and pause your video, come on back when you're ready, and finish with number 5. Recalling, please, what we said about something that is linear. Does it increase by the same amount? Well, I see this goes up by 3, and then it goes up by 5, and then goes up by 7. There is a pattern, but it is not a linear pattern. It does not have a common difference. There goes A. Now we take a look to see if is there a multiplicative difference. So in this particular case, 3 times 2 is going to give us 6, but 6 times 2 does not give us 11, nor does 11 by 2 give us 18. There is no common ratio as well, which means what we're heading to here is there's something different going on. There is a new type of pattern here. It does not have a common difference, nor does it have a common ratio. So what is this new type of pattern, and how else will we be able to see it? Go ahead and take a look at numbers 6 and 7. Pause your video. Come on back when you're ready. I see what might seem obvious, but I see 2 patterns that are increasing, both growing wider, both growing taller, and interesting that the rate of change is different. So here we go from 3 blocks to 6 blocks. It goes up by 3 blocks. But then it doesn't go up by another 3 blocks. It will go up 5, from 6 to 11. Here it seems to add 1, 2, 3, 4, 5, and then it seems to add 1, 2, 3, 4, 5, 6, 7. So their rate of change is not a constant rate of change. I guess you could say then that neither are linear. They're both nonlinear. All right. However, what is different? Okay, start with the obvious ones. Purple, one's orange. I've heard students do that in the past. But then go a little deeper, and you'll see that first. Oh, I just erased it. Can I bring it back? In this case, the purple increased by 3 at the beginning. This one increases by 5. Then there's a 5, but the next one increases by 7. So the rate of change is different. Now, Abdullah says, I see a square plus 2 rows. Deja, on the other hand, sees it differently. She sees a rectangle where the length is 2 more than the width. I'm going to pick one. I'll just pick Abdullah. So I see a square and a row, another square and a row, another square and a row. If, however, you want to focus more on what Deja's saying, she sees a rectangle where the length is 2 more than the width. So if the width is 1, the rectangle is 2, the length is 2 more. Here the width is 2, the rectangle is 2 more. Here the width is 3, the rectangle, the width is 2 more than that. So you can see a little bit more. How can you use either of those to find the fourth? Think about that. And let's wrap up with number 8, please. Pause your video, come on back when you're ready. We are asked to determine that. So I'm going to go with that square idea. So we have 1 times 1, and then 2 sets of 1. 1 times 1 is 1, plus 1 plus 1. Naturally, that's 3. Then I see not a 1 by 1, but I see a 2 by 2, and then 2 sets of 2. So 2 by 2, there was 4 squares on the bottom, and then 2 more is 6, and 2 more is 8. Onward we go to a 3 by 3, and then add a 3, and then add another 3, which means 3 by 3 is 9, plus 3 is 12, plus 3 is 15. So what would 4 be then? You can probably see the pattern. We're going to have a 4 by 4 square, and then we're going to, on top of that, an additional row of 4 and an additional row of 4 on top. So 4 by 4 is 16, plus 4 is 20. I hope you found 24. Again, if you haven't gotten to 10 by 10 yet, go ahead and pause the video, come on back. 10 by 10 is going to be 100, another 10 and another 10 will lead to 120. Now listen, you could have done the other way as well. Remember what they said. I believe it was Miss Deja that said, I see a rectangle whose length is 2 more than its width. 1 by 3 is still 3. Width of 2, the length is 2 more. So that would mean a 2 by 4, still 8. A width of 3, whose length is 2 more, leaves us with 3 by 5, or 15. Width of 4, whose length is 2 more, 4 by 6, or 24. And then width of 10, whose length would be 12, still gets us to 120. So this is not surprising to you that we can see different patterns in different ways and still arrive at the same proper destination. If you're interested, you can go ahead and pause the video, explore some more, make your own, and with the guest teacher's permission, show it to your partner, see if your partner can figure it out. But I'm going to pause right here. How would you help a classmate who's trying to understand, describe a pattern? Focus on words like increase, decrease. Does it go up by the same amount or a constant ratio, constant difference? Then there would be what's called a linear pattern. If it goes up by a constant ratio, that would be an exponential pattern. And in fact, I can find down here, because this does seem to be increasing by a constant difference every time, that means quickly it's going to be a linear pattern. I can tell right away. And then we can use that linear pattern to find other steps in the relationship. That's all I have. Actually, if you want to pause your video and do a few problems in the next couple pages, I'll show you the answers in just a second. All right, number 1 is going to be B, D, and E. Number 2 is going to be 110. Now, you don't have to see it the way I see it. I did a square and then another row. 3 is exponential because it has a common ratio. It seems to multiply 3 every time. Number 4 is a Chiro. You can't really tell. There's just not enough information. But if you were to look at the next part and say, okay, if it's linear, what would the next one be? Well, this would go up by 20, which means the next one would go up by 20, leading us to a third step of 45. On the other hand, if it was not linear, if it was in fact exponential, then I notice that 5 times 5, or the ratio of 25 to 5, is 5, which means we'd have to multiply by 5 again, and 25 times 5 leads us to 125. But that's what we're saying, is we simply don't know. We did not have enough information from just 2 data points. Number 7 is going to be the time frame from noon to 4. You can look at my work just briefly. And number 8, 9, and 10, some of them have multiple answers, as long as yours is an equivalent expression. That's all, folks. Go ahead and jump into your homework. Take care, do well, and let's grow.